Okay, so 3, 6, roots of polynomials. Roots are x-intercepts, are zeros, are solutions. So you've been doing these. So we need to figure out how to find the roots when we have higher degree. Yesterday, they would tell you one, and then you'd have to find the rest. Today, they're not going to tell you any, and you have to figure them out. So how we're going to do that is a rational zeros test, okay? And we call this the PRZ. What do you think PRZ stands for?
Possible rational zeros. Rational.
Yep, possible rational zeros. Okay, possible rational zeros. Rational are don't have square roots and are real. Okay, that's what a rational number is. It can be a fraction, it just cannot have a square root, and it can't be imaginary. Look in this way. Okay, you take the factors of the constant divided by the factors of the leading coefficient. So you first have to have it in order, correct? Always. So the factors of the constant, so this factor is -8, the constant is -8, and the leading coefficient is 4. So the factors of 8 are 1, 2, 4. Actually, it'd be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8, divided by the factors of 4, which are plus or minus 1, plus or minus 2, and plus or minus 4. Now, that doesn't look bad, and this is how I will take your answer, but when you're putting it in the computer, when you do the Math Excel on Thursday, you actually have 3, 5, and 3, 6 on Thursday. You have to put them individually. So you have to put them all over 1. So that would be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Then you have to put them all over 2. So it would be plus or minus 1/2. And 2 over 2 would be 1, which we already have covered. Correct?
Yeah.
And 4 over 2 would be 2. Do we already have it covered? 8 over 2 would be
4.
And do we already have that covered? Okay, then we move to 4. So I have plus or minus 1/4. And I already have a half. And I already have 1. And I already have 2. So there are 1, 2, 3, 4, 5, 6. There are 12 because they're positive and negative. There are 12 possible rational zeros. Now, they aren't all. There's only what? At most 4, correct? But does this, out of infinity, give me fewer to look at? Mm-hmm. Yes. Okay. So then the next one. So the PRZs. Okay, the constant's 45. What are the constant? The thing is 45. The factors. Couldn't say the word. What are the factors of 45?
9 and 5.
So 1. So I'm just going to put the plus and minus on the 1. And 5.
3.
Oh, 3 goes there first, right?
Yep.
3 goes in there. 4 doesn't. 5 does. 6 doesn't. 7 doesn't. 8 doesn't. 9 does. 15. And 45. And the plus or minus goes with every single one of them. Got it? Now, again, if you're putting into the computer, you got to put them like this. Okay? Over the factors of the leading coefficient.
1 and 7.
1 and 7.
Plus or minus.
Plus or minus. Okay, so on these, it'd be 1, 3, 5, 9, 15, 45, right?
Yeah.
And then 1/7, 3/7, 5/7, 9/7, 15/7, and 45/7.
Okay.
Make sense? Okay. So, what are all, well, it says concept of fundamental theorem of algebra. Okay, we just did the fundamental theorem of calculus the other day. In calculus, there's a fundamental theorem in most math classes, But the algebra one says if p of x is a polynomial of a degree greater than 1. So anything other than x, like 2x, right? Anything other than that. Has exactly n solutions in the complex number system. So, thank you. You're welcome. Thank you. Okay, so that means whatever your largest degree is, that is how many zeros this thing has. But I said in the what number system? Complex. So does that include imaginary numbers? Yes. Okay, your PRZs are not going to give you imaginary numbers. That comes down when you do your quadratic formula because you can't factor it. Those where that would come from. So this polynomial that I have here, how many zeros does it have? Four. It has 4. Did I say 4 real zeros? No, I said how many zeros does it have? Make sense? When we first talked about zeros, we say at most 4 zeros because we only know real numbers. Now that we know real numbers, we say there are 4 zeros. Again, did I say real? No, I said there are 4 zeros. Make sense? There's 4 zeros, 3 turning points because the 3 is 1 minus. Okay? So that's what it's saying, that the fundamental theorem of algebra is saying whatever the degree of the polynomial is, that is how many zeros it has. That's it. Okay? So, what are all the complex zeros of this polynomial equation? So the first thing I would do is I would give my PRZs. So plus or minus 1 and 2 over 1 and 3. Okay, so yesterday when you knew what a zero was, you used synthetic division and you knew you were going to get a remainder of 0, correct? Today we're going to use synthetic division, and if we get a remainder of a 0, it is a 0. If we don't get a remainder of a 0, is it a solution? Is it a root? Is it an x-intercept? No. Does that make sense? So yesterday they told you it was a 0, so you knew you were going to get 0. Today, do I know if I'm going to get 0? No. So we have 1, 2, 1/3, and 2/3 to choose from. Where did I get 1 and 2 from? 1 and 2 over 1, correct? Where did I get 1/3 from? 1 and 3. And then 2/3? 2 and 3. Are we going to start with choosing 2/3 or 1/3? No, we're going to start with 1 and 2. I never start with a fraction, ever. I can't tell you a time I have. So, is it in order? Is the polynomial in order?
Yep.
Any gaps? Nope. Okay, so what do you want to start with? 1, 2, positive, negative?
Probably positive 1.
Positive 1? Okay. So, and I'm going to tell you, if I have choices, I usually never start with 1. Because there's odds of 1 being the answer is probably not very good, right? But we only have 1 and 2. But I'm saying if I have a wide variety, I never start with the smallest or the biggest. It just doesn't make sense usually. Okay, so 1, I get 3, 3, 7, 7, 9. Can I stop? Is this going to end in a 1 or 0? No, because I'm not going in the right direction, am I? Once you start doing this, you're going to see really quickly that it's not working. So 1 didn't work, so I usually go back and just make it a negative 1 because that's easy to fix. Okay, so this would be negative 3.
Oh, boy.
So then I get 1, negative 1, 1, negative 1, negative 2, 2, 0. Okay, so did negative 1 work? Yes. So we started at a 4th degree. This is a 3rd degree, correct? Because it goes down by exactly how much? 1. Now, we can do this again. We can do our PRZs again because our constant would be negative 2 and our leading coefficient would be 3. Yes? So if they had changed, sometimes it makes this list smaller. Does that make sense? Here it didn't. We can do factoring by grouping sometimes, but when we're to a cube, we probably just want to do another number. We already figured out 1 didn't work the first time, so is 1 going to work this time at all? No. Okay, so 1 is a no. I usually cross it out. We can try -1 again, or we have 2 or -2. What do you want to try? Dylan, what do you want to try? 1 or -1, -1, -1, -2, or 2? 2? Okay. So 2. So 3, 6, 7. Can I stop? Yeah, because it's going the wrong direction.
Probably negative.
Probably negative. Because we have a lot of positives, we probably want to throw in a
No.
negative. Will this guessing get easier as you see different examples?
Yeah.
Yeah. Okay, so negative, I shouldn't erase that. Would it be a -6? -5, 10, 11. Is that going to work for me either? No. I'm pretty sure not, because it's going to go negative. Yeah.
22.
Yeah. So do we want to try? So we figured out positive and -2. Neither one of those work.
Probably -1.
So positive and -2 is a no-go. So you want to try -1 again before we head to the fractions?
Yep.
Okay, because it can have a multiplicity, can't it? Okay, so 3, -3, -2, 2, 3, -3. Did that work for me? No. Okay, so all my 1s and my 2s are out. So you want 1/3 or 2/3?
2/3.
2/3?
I don't know.
You guys want 2/3? Negative? Since we figured negatives are going to work better? Yeah? Okay. So then that's 3. So -2/3 times 3, the 3's are going to reduce, and I'm going to have what? -2? So it's -1. If it works, am I going to get nice numbers?
Yeah.
Yeah, because it has to head to 0, doesn't it? So then that would be +2/3.
So it'll be 1/3. No. 1 is 2/3.
Well, and this would be 3 over 3. So it'd be 5/3. So then I multiply it. Oh, that's not going to work, is it?
2/3.
Because that would be -10/9, which would not be 0, would it? Because this would be -10/9. And I'm not going to get 0 that way, am I? No.
Okay, let's try 1/3.
1/3? Because I think we've established the positives aren't going to work, are they? Okay, so 1/3 now? Negative? So then I get -1, so I get 0, I get 0. Oh, zeros are nice, right?
1.
1 and -1/3, is it going to work?
Oh, no.
No, that's not going to work either. So we didn't try positive 1/3. I don't know if it's going to work, but I guess we can't hurt, right?
I guess.
It might hurt. So I still get 1. So then I get 2. So I get 2/3. So 5/3. Then I get 5/6, which is not going to give me 0, is it? I feel like we've done one of them wrong. What didn't we give a chance?
Yeah, it's this.
So we have x cubed plus x squared plus x minus 2. We could factor by grouping, but are these going to group and get the same things?
No.
Nope. Okay, what do we want to go back and try? What?
2 plus 2.
Plus 2?
I'd be making everything bigger. I think.
Yeah, that didn't work. So negative made it -6. I still don't think that worked, did it? And then -5. And then 10 and 11 and -22. Okay, so we want to try 1 again? I didn't open my book. So 3, 3, 4. Can this take forever if you don't guess right? Yes. Okay, you guys try -1 and see if we messed that up. I was going to open my book and see what it is. I don't know. It's been a year since I did it.
We suck at this. Shut up.
You're a horrible person.
Annoying.
Okay, they got 2/3 to work.
Positive 2/3?
Yep.
Okay, why
Did we
not?
ever?
Guess that.
Did we ever try positive 2/3?
No, we did.
No. That's like one that we didn't go back and try the positives of those, did we?
Well, let's just give up.
Okay. No. So does it tell you like we were trying to avoid those, but should we have been avoiding them?
Yes.
No. And we probably should have been a little bit more systematic on what we were trying so we remembered what we tried.
Yeah, that's
So 2/3. So we get 3, and then we get 2, and then we get 3, and then we get 2, and then we get 3, and then we get 2, and 0. So did that work out for us?
Yeah.
Okay. So now we have, bless you, we have 3x squared plus 3x plus 3. And so can I get the factors of 9 to add to 3?
no.
Nope. So I have to use the what? If I can't factor it, I have to use the what?
The
Quadratic formula. So x equals, what is the quadratic formula again?
plus or minus.
Nope. Negative b plus or minus.
Plus or minus the square root of b squared minus 4ac over 2a.
Okay, are you going to have to use it?
Yeah.
Yes.
Negative b. Okay.
Okay, so then it's what? X equals -3 plus or minus 9 minus 4ac, so 4 times 9 is 36, over 2a, so 6. So this is going to be -27.
Mm-hmm. Minus 3.
So 3, so -3 plus or minus 3, the square root of 3i over 6. I can take a what out of all of it?
3.
So my zeros are x equals -1, 2/3,
Oh.
and -1 plus or minus the square root of 3i over 2. So what are my real ones that I'm going to graph when I get there? -1 and 2/3. This, remember, is just going to put a little wobble in that graph. Okay, so we got to get better at guessing, right?
It's your fault. We didn't run them off to the side.
Yeah, I know. I should have been more systematic about it.
Yeah.
Okay, what are all the complex roots of the polynomial function x cubed minus 2x squared minus 5x minus 10? So we only have to do it one time to get it down to a quadratic, correct?
Yep.
Okay, so sometimes that's nicer. So the first thing I write is my what? The PRZs. What does PRZ stand for?
Possible
rational zeros.
Okay, so what goes on the numerator?
Factors of constant, which is
1,
Yes.
2,
5.
Okay, 1, 2, 5, 10. What goes on the bottom?
Factors of leading coefficient, will it be 1?
1.
1 and 1. That's amazing to hear, yes? Because now I only have 1, 2, 5, and 10 to choose from.
Yep.
Okay. Again, I would not choose 10 usually my first time, and I usually don't use 1, but that's up to you guys.
2.
2? Positive or negative?
Positive.
Positive.
Sure.
Now this one is like plus minus, so it could go either way, right?
Yeah.
Any holes, gaps need to be reordered?
No.
Nope. And we should have reordered it before we did the PRZs because you need leading coefficient and constant, right? So
2 words.
1, -2, 5, and -10.
Yep.
So 1, 2, 0, 0, 5, 10. So 2 worked. Awesome. So now I have x squared plus 5.
Mm-hmm.
Well, I don't even need to use the quadratic formula on this because I can just set it equal to
0.
0.
So,
So
you get
x
x squared equals -5, take the square root, you get x equals plus or minus square root of 5i.
Square root of 5i. Good job.
Good job.
And what else?
2.
2.
Yeah. Forget about that one.
Because
Well, that's
we found it first.
Then you should have known that.
Yeah.
We found it first.
I didn't say it.
Okay, so this is going to lead us to what we did yesterday, to graph it. Okay, do we have an even or odd function? Okay, focus. Even or odd?
Even.
Even or odd? Odd. Positive or negative?
It's positive.
Positive. So it goes, ends up, starts. Jenna, do you need to move?
No.
Then stop. So we know it goes there. We know it goes through 2. Is 2 a double zero at all? No. We only divided by it how many times? 1 time. We know that the y-intercept is -10, don't we?
Yeah.
Okay. So it's going to do some sort of wobble here, right? And then go up.
You put it at 0.2.
Because it's an x-intercept.
X-intercept
And
is
what's
2.
the odd for?
The end behavior. End behavior that we did before. Okay, so this is going to lead us to graphing just like I did yesterday. Okay, so the conjugate root theorems we talked about yesterday. If I have a plus bi as a root, what do I also have? A minus b. I shouldn't have said I, but yes, either way. So if I have, that was the square root. So if I have a plus the square root of b, I also have a minus the square root of b. If I have a plus bi, I also have what? A minus bi. Always, 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 because I got those by taking the what? Square root, and the answer is always plus and minus. So I put both complex and irrational together. Always. So if I tell you one is a root, the other one is automatically a root, correct?
Yeah.
Okay. So, write a quadratic function p with rational coefficients in standard form such that p of x has equals 0, has 2 plus 5i as a root. Okay, so I want the polynomial. I'm going backwards. The last ones we've been doing is give me the roots, yes? I want the start. So to go from the polynomial to the roots, I divided. So to go to the roots to the polynomial, I have to multiply. I have to multiply out the factors, correct? So I told you one factor, well, one 0 is 2 plus 5i. What do I also know is the other one?
2 minus 5.
2 minus 5i. So to go from zeros, when I went from factors to zeros, I set it equal to 0, moved it over, yes? So now I have to move it what? Back. So this is one, and then this would also be another one. So we have 2 different operations, 2 factors, yes? So to move it back over to the other side, I would subtract. I'd have x minus 2 minus 5i. Correct? Because I moved it back over to with the x. So if I want to move this back over with the x, I would have what? X minus 2 plus 5i. Do you still see the conjugate part? Yes? The 2 is both negative because the only sign that changes in the middle between those two terms. Got it? Now, what do I need to do with these two now? What do the parentheses tell me to do?
Distribute.
Distribute, multiply. So I have to FOIL, distribute, box, whatever you want to do, but you have to do it. So we have x squared minus 2x plus 5i. And then I have positive 4, right? No, let me do it. Negative 2x, positive 4, and you guys didn't catch me. That is not 5i.
Yeah.
No, that is. That's plus 5i. Yeah, it is x. So negative 2 would be negative 2x, positive 4, and negative 10i. Guys, I'm just distributing. Okay, I'm not going to do it, then you have to do it because you're not, do it on your paper. So our was x minus 2 minus 5i and x minus 2 plus 5i. I want all of you to do it because you were not doing it with me. You were just waiting for me to write the answer. Do it. Multiply. Slash chapter. Don't whistle, please. Okay, you should have gotten x squared minus 4x plus 29. What's wrong, Carson?
I forgot that I squared is just
Negative 1?
negative,
Okay.
I did the same thing.
So, do you now know why we did chapter 2 before we did this in chapter 2 before we're doing it chapter 3? Or did we do it in this chapter? I don't know. It's been a long chapter. So, I squared is negative 1, so negative 25 times negative 1 is positive 25, and you combine your like terms. Now, the whole point of conjugates, the same as they were last time, is when I'm done, do I have imaginary numbers in there? Do I have any, is that a complex number? No. The whole point of it is we don't have polynomials written with imaginary numbers, do we? No. So, make sense?
I mean, yeah.
Yeah? Okay. So if they told you like x equaled negative 3i, what do you also know?
X equals positive 3i.
X also equals positive 3i. So that would be x minus 3i and x plus 3i. Would that be easier to multiply?
Yeah.
Yes. Okay. But is it the same process either one? Okay, we're going to do another one of these because these are harder. Okay, so I know that x equals 5 plus 4i. I also know it equals what?
X,
5 minus 4?
Yep. So x equals 5 minus 4i. So when I move those back over to factors, what do those factors look like?
X minus 5 plus 4i. I guess. X plus 5.
Nope. Still minus
X
5.
minus 4i.
Okay. That first sign needs to match. If it doesn't, you won't zero things out. Okay? If that doesn't, you would still have an I in there, which would make it wrong. Okay, so multiply that one out. Hopefully it goes better this time. Honestly, anything with i's other than I squared, do you even need to put down? No, because it should zero out, correct? Did you get x squared minus 10x plus 41? Okay, what if it also told you, like, what if it said 5 plus 4i and 3 and negative 4? So you would have x minus 3 and x what? Plus 4? So how would you do this problem? You would multiply these two together first, right? You probably then would multiply those. So that would be x squared plus 4, so plus x minus 12. And then what would you have to do with those two? Then multiply those. Make sense? Okay. What if they had an I on this 4? Then it would be 4i and minus 4i. And I would hope you would do these two first, right? Get it off those imaginary numbers. So you just keep following what it says to put, right? Okay. I'm checking. I think this might be, yep, this is our last example. Okay. So I want a 4th degree polynomial. So if I only gave you 2 zeros and wanted a 4th degree, you'd have to square them, right? You'd have to add those zeros in twice. Okay, I want a 4th degree polynomial, and the roots are x minus the square root of 3 and 5i. So I know that x equals plus and minus 5i. Okay, plus and minus 5i. And if I have 2 minus the square root of 3, I also have 2 plus the square root of 3. Only works with square roots and imaginary numbers, not anything else. Is that 4 zeros? Is that 4 zeros? Plus and minus?
Yeah.
Yes. So is that going to take care of my 4th degree when I have this multiplied out? Yes. So I need to make my factors. So what are my factors for my 5i's?
1 5.
So, no. X minus 5i, x plus 5i.
Sorry.
Yeah, you were thinking like factors. Yep. Okay. So what about the next one?
X
Nope.
Minus.
Minus because you have to do what? Move it
the
over?
same thing you have.
You have to move it over. So x minus 2.
Square.
What do you want? Plus or minus first?
Plus.
Plus the square root of 3.
And then x minus 2 minus square root of 3.
Okay. So when we have these, we're going to multiply these two together and we're going to multiply these two together because they're the conjugate pairs, yes?
Yes.
They're the ones that are going to make it nice to work with. Okay? So I'm going to pause the video. We're all going to do this. And then I'll unpause the video when we have the answer. Okay, so we're all doing this. And you got 2 minutes to do it. Actually, so I won't unpause the video. I'll let them watch me do it. If you know your patterns, it will go a lot easier.
I forgot it, but I have it now. But why did you put x in front of the square root of 3?
Because x times the square root of 3.
What? I got the first one.
Okay, so do the second one. The last multiplication is really easy because there's no like terms.
What the? Wouldn't it be minus 200?
Yes, it would be minus 100. You're correct. Okay, so there's your. What you're doing
Is that
today?
the answer?
Yep.
So we got
I was gonna.